So there are a few special circumstances that we have when we are working through this. We are going to talk about areas under the x-axis. So the figure to the right shows the graph of f of x. The areas between the graph and the x-axis are denoted by the values a and are the same size. The difference is that when I'm between 0 and a, I know I'm above the x-axis and I have a positive area. But when I'm between A and B, I'm below the x-axis, which actually makes the area negative. A couple of interesting function transformations, just to kind of revisit them, as here's a graph of f below. Hopefully you're recognizing that that's the sine curve. If we plug a negative x in there, this graph is shown below. So notice that it went from the kind of grayed out line to the green line. It kind of basically flipped across the y-axis, which actually makes it an odd function. Which, if I'm thinking about it and I go back to my definition of odd functions, it ends up being y equals negative x, because when you plug a negative in, you get the negative of the function. And then the other graph that's interesting is this is f, the absolute value of x is shown. And this is a reflection of the positive side of the graph across the y-axis. So we're going to assemble some areas. The figure at the right shows the graph of f. The areas of the regions between the graph of f and the x-axis are labeled, and it is known that from c to 0, so from c to 0, my area is 3. If it was me, I would probably put a negative sign on these ones that are underneath the axis, so I remembered that. All right, so let's see if we can find each one of these areas. So if we're supposed to be going from 0 to E, and it looks like from 0 to E would be negative 7 plus 10, which is 3. I am now supposed to be going from B to D. So B to D. So I would do negative 5 plus 3 minus 7, which is going to be negative 9. I am now doing the absolute value from A to 0. So that means that I need to, basically I'm going to take the absolute value of each one of those areas. So I am adding 15 plus 5 plus 3, and that's going to get me 23. Now the next one is a bit different. Now it's saying the absolute value of the entire function from A to 0. So what that means I do is I add together the values in here first, 15 minus 5 plus 3, and then I take the absolute value of them. So I get 13, which would be the absolute value would be 13. Oh, interesting again. Now we have the absolute value inside the function. So I am supposed to be going from negative E, to negative E. Interesting. Okay. I'm not sure I'm reading that right. Negative E to E. Negative E to E. Okay. So what that's telling me is that I'm going to have this piece of the graph over here basically twice, right? Because I've got to go from negative E, wherever that is over here, all the way to E, and it's going to be symmetric on each side there. So, but I'm doing the absolute value on the inside. So I'm going to basically take the signs for what they're on there for. So I have to have 10 and negative 7, and then I'm going to have a second set of that 10 and negative 7. So that's going to be end up being, when I add those together, that's going to be 6. Next, I'm going to go ahead and do some erasing on my graph here a little bit. Okay. So next, I'm supposed to be going from negative C to negative A. So negative c to negative a, and then I'm supposed to be finding the negative of the values. So negative c to negative a is really not going to be any different than from a to c. So it's going to have the same distance in there. So I can use the values that are there. And then I'm supposed to be doing the negative x, which is just indicating that it's an odd function. So I'm going to just use the areas that are there because that doesn't change the area of my function. So I just would add up the 15 and the negative 5, and I would end up with 10. All right, let's take a look at example 3. So we're going to integrate a function with a discontinuity. We're supposed to evaluate from 0 to 5 f of x. So I'm going to graph the function basically and shade it, and then we're going to try to find the definite integral from the areas. So I'm starting with a y-intercept of 7. So 1, 2, 3, 4, 5, 6, 7. And I'm going to count down 2 over 1 until I hit the 3. So you notice I hit 3 right there. So there is one of my functions, meaning that I am going to be finding the area of that trapezoid. Now I am going to graph my other function, which is a horizontal at 4. 1, 2, 3, 4, which is going to start at 3 and go all the way until I stop here at 5, which means I am also finding the area of that rectangle. All right, so let's find the area of the triangle, or no, trapezoid. So 1/2, or divide by 2, the bases, which looks like a height of 1 and a height of 7, and then the height of the thing looks like it's 3. Making sure I'm doing this right, yep. And then I'm going to add that to the area of this rectangle, which looks like it's had a base of 2 and a height of 1, 2, 3, 4. All right, we're going to do the arithmetic. So let's see, we've got 1 plus 7 is 8 times 3 over 2 plus 8. 2 goes into 8 4 times. So we've got 12 plus 8, which is 20. As always, make sure you've got a couple of comments or questions out in the left-hand column, and make sure you are completing your summaries.